Okay, so it's not flush against the axis. It means the region that is being rotated. Sure. So we have a region being rotated. Since it's being rotated, we can say that the radius is dependent directly on the region. However, if the region is not flush with the axis, can we just do top minus bottom? No. We can't just strictly do top minus bottom as though it was an area of a region. If you do top minus bottom, which is what the AP guys love to include in the answer choices, you will be wrong. Right? Instead, we have to think of the whole and the hollow. True? Yeah. How can you, when looking at a figure, maybe not the three-dimensional, because most of you don't make this three-dimensional when you're looking at it. If you just see this region, the green, and you see the axis is down here, and you follow it and say, ooh, it's not flush, how do you visualize or think about the whole?
You subtract it.
What?
The part that does go flush.
Not necessarily, it doesn't exactly have to go flush at all. This one only hits at one point.
The whole radius minus the...
Yeah, but how do you visualize, how do you find the whole radius?
Rotate the thing around the axis.
Okay, if you can visualize rotating, then yes, you can think the outermost edge minus the innermost. And the innermost will always be the axis of revolution. So instead of thinking of the outer, because sometimes the outer, to be honest, might be below. Be careful. Always think the axis to the outer. That's going to be the whole radius. Then think the axis to the edge of the hollow. The axis to the outer shell and the axis to the hollow, right? So for this one, the axis of revolution is the x-axis. Not always true, but in this example, true. We go from the axis to the outer of the entire thing, to the outer shell. Do you see why we're on this top function? Do you see why we're on the top function? That'd be TW, or the top of the whole. So from the axis to the outer is going to be the whole radius. So top minus bottom. Is this function included at all in the whole thing?
No.
This is not included at all. Because I'm just saying, hey, in order to make this figure, in order to make, if you're going to put this on a lathe or something, you need the entire piece of wood or material. Then you need to hollow out, but we need the whole thing first. So from the axis to the outer edge, remember, that is the whole radius. And then for the hollow radius, I need the edge of the hollow. I need the edge of the hollow to the axis of revolution again. Hence why I have the hollow top and the hollow bottom. So I have two different subtractions. I have two different pi r squareds. Yes, you can bring the pi out if you want, but you still need two different top minus bottoms, and that's only if you are rotating around a horizontal axis. Because a horizontal axis will have a horizontal depth, which means dx. Katrina.
Is the B sub W and B sub H just the x-axis?
In this one, yes. But in general, it'll always be the axis of revolution. But the axis of revolution is sometimes above your region, at which point the axis would be your TW, TH, and then your functions would be the B's. Does that make sense? Mm-hmm. Yeah. So, ready, set, go. Oh, come on, babies, let's go.
Let's do it.
If you want to sketch it, even better. If you don't, totally fine, you don't have to. You're rotating about y equals -1.
Wait, is that the axis? Wait.
Yes.
They're going to be natural bounds, aka find the intersections. I just happened to draw the picture to come. Maybe I shouldn't have, but I was being nice. If there was no picture, you should be able to find it. The bounds are natural, not defined.
8.
Huh?
No. Yes. No.
Square root of.
Yeah. Oh, no, you do it? Oh. What?
You do you. Intersections.
Intersection minus root 8?
I know there are 2 root 2.
Oh.
Root 8. Negative and positive, yeah.
So that's the other one?
Negative and positive, I think, plus or minus square root.
Plus minus root.
Those who are wondering why they're like, oh, the numbers are gross. They're finding the intersections. That's okay. Bounds make sense?
Yeah.
Subtract 4, -2, -2 times -4 is 8. You're doing it around the x-axis. It's around y equals 1. -1. You have to consider the axis of revolution. The whole end. Times. We take a 1/4 out of students.
Wait, do you add them?
So you gotta figure out how to visualize it.
I don't know.
If you need to visualize it, visualize it. Get the axis of revolution. I just said you need to go from the axis to the outer and the axis to the edge of the hollow.
So 3 minus.
The axis to the outer and the axis to the edge of the hollow. That's a huge hollow. The axis to the edge of the outer and the axis to the hollow.
Oh, okay.
It's not bad, but can you do it? I can do it, of course. Can you?
There's no
Axis to the edge of the outer, axis
What you got?
to the edge of the hollow.
Yeah, right? It was +1.
It's hard. I have to integrate.
Does it make sense, the picture?
It was just
So-
when you put the line at the end.
Yeah, identify who's top and bottom for big R and who's top and bottom for little r. Plug into pi big R squared minus pi little r squared. You see it? Wait.
All right, I got it.
You don't have to separate it out. I
Man,
know. There's
Oh,
symmetry.
wait, how come this time you can do 2?
Good question.
Symmetrical? Symmetrical? Gotcha. Gotcha.
Wait, why?
I'm just being lazy. I'm just being lazy.
It's symmetrical.
Oh, she only put it in the
Oh, okay.
That makes sense.
Well, it wasn't technically +1, it's minus a negative. Question, why am I being lazy? Why is there a 2 pi?
It's
It's symmetric, it's even, so therefore it can go from 0 to 2 root 2, which is way easier than -2 root 2 to 2 root 2. But I just have to double the region. I can double the volume the same way I double area when there's symmetry. I have to do top minus bottom, because it said so. Gotta read those directions, cool kids, might have to write them in homework. You could always read perfectly, I wouldn't have to do them, but do not read, process. Hey, kiddos, long story short, if you needed to, would you take your time and solve this?
No.
If you needed to by hand?
Yeah.
Sorry.
Fine, you had the time, and you were trying to do well, which hopefully all of your answers are yes. Would you take the time to do well?
Yeah.
Okay, good. We have the setup.
Yeah.
Good. Questions on the setup?
Oh, wait.
If we were doing from negative square root h, like put down.
there just would be no 2.
Is that the reason?
I only doubled because I was lazy and want to go from 0 because that's going to be an easier bound to pedal.
Okay.
So I took half and I said, hey, that volume times 2. But you could have just said pi r squared, just taken out the 2 and gone from -2 or 2 to 2. Any other questions on the setup though? You okay? Okay. I want you to set up, not solve. Now, in homework, if it says solve, you solve. But if it's a decimal, you could use your calculator. If you want to check in the back first, I guess you can. But I want you to set up, not solve. You guys know the AP asks you that from time to time. Set up, not solve. The exact same region, the square root of x from 0 to 3, you guys should know how to get that picture if you needed it. The other restriction would have to be the x-axis, hence the 0. But what if you were revolving about the x, about the y, about x equals 4, and about y equals 5? Woo! Ready, set, go. Dishwashers? I don't know. You figure it out. Take your time. Give people a chance to think about it. Draw or visualize each axis of revolution separately. You have to visualize the axis. Is it flush? Is it not? Is it dx? Is it dy? Take your time, set it up. And technically, I would draw them separately so I can visualize each axis like I did. Visualize each situation. They're all unique. Flush again, so letter B, right?
Nope.
writing in simplest form, I'm writing in the full, my rationale and reasoning. P.S. real quick. Letter B, as long as you have associated, have related everything properly, the dy goes with the expressions and terms with y go with y bounds in the integral. Can you plug that in your calculator and just treat it like x for sake of quickly inputting? Yes. The calculator, when you write x in your calculator on the home screen with the integral, all it's saying is block, all it's saying is variable, all it's saying is, okay, cool. You have to get everything in there properly. Get the y squared, not the square root. Get the 0 to root 3, not the 0 to 3. You associate everything. But when you go to your calculator, you can do alpha y if you want. But you can just use the x button too. It doesn't make a difference as long as you have properly, legally set up your integral so that the bounds match the expressions, match the differential. What? Match the axis of revolution. Questions on B? Grab a little harder. I needed y bounds, expressions in terms of y. Do you guys see how I used my axis to outer and my axis to the edge of the hollow? Axis to outer, axis to edge of the hollow. And I knew I was having to move horizontally because my axis was vertical. And we always go perpendicular when doing discs and washers.
Oh, she said block, I thought
Flush or not flush for C?
No,
dx or dy for C? Good. Wait, the axis is outside the region in a direction I'm not used to. But can't I still go axis to outer and axis to edge of the hollow? The process is the same. Don't get tricked by that. Last year, a lot of you got tricked by that. Well, and a lot that aren't in this room right now. But you guys got it? How we doing? Remember, take the right minus the left. This one it was the region minus the axis. This one is the axis minus the region. Now, technically, if you switch the two, as long as you have these in there, when you square it, is that really going to mess up your calculation? No. I don't think I've seen, in a multiple choice answer, I don't think I've seen them switch the order where the integrals would evaluate to be the same. But, to be proper, should we probably, for an FRQ, put it in the best possible form? Yes. I don't actually know if they would take off points if in an FRQ you wrote but did not evaluate. I don't think they should because it does evaluate to be the same. However, technically in the AP grading, if you make a mistake in notation or in writing, even if your answer works out to be the same. Hence why, not a huge fan of that. Right minus left, right minus left. Was there a question? What's wrong?
For C, I did y squared minus.
That's what, well, okay. That's what I was just talking about the last 2 minutes. Focus. Because you would have tracked it. Focus. Technically, right minus left. If this was, for instance, like a square or a rectangle or a cross-sectional area, you would need to do, let's put it that way, you would need to do the larger 4 minus the smaller. The same way we did function minus the smaller. Right minus left, it would be 4 minus y squared. Now, I was saying, mathematically speaking, because of the squared, because you're doing the revolution, technically, mathematically speaking, does it matter if these are switched? No. But to be proper and to be aware for cross-sectional areas, etc., if we had something similar. the axis would need to be subtracting right minus left for the orientation to be correct. And as I was saying, the FRQ graders, even though the answer works out to be the same, can they technically take off a point if they think there was a mistake made earlier? Yes, so just be aware.
I'm so confused about like why.
Okay, who's bigger? Right now, if you were to plug in at 1, square root of x, that's 1, right? Is the x value 4 bigger or smaller than the x value of 1? Bigger. So we need to go bigger minus smaller.
So you thought of it as a big thing because I'm just picturing like.
I was trying to figure what it is.
Like the big hole.
Okay, imagine a bowl that's solid, and you've drilled through a cylinder. That's what this is. You put a candle in it. Boop. That's what this shape is. You're just trying to figure out the shape. This is a
I
cylinder.
thought the whole shape would be just y squared. So.
There's a hollow, a candle's been put in, and there's this like bowl on the outside.
So I'm just confused about
The shape?
like if I imagine without the hollow, the whole shape.
The whole shape is a bowl that's solid with like a level part on top.
Yeah, I'm just confused why you put.
Because it's bigger. It's higher as a numeric value,
Oh, that's.
and I want it to be positive. So whenever you're doing area, we always do top minus bottom, right minus left, unless we put on the well, thanks, Ellen.
Okay.
Thanks for all your work that you did. So whenever we're doing any sort of geometric, it always needs to be positive, which is why we always make the orientation to be the bigger number minus the smaller number. 4 is the bigger number. 1 would be the smaller number. So if you're thinking horizontally, we always pick the right minus the left. So 4 is to the right, this is to the left. Functions to the left.
Oh, okay. Because I'm thinking of like going axis to the outer edge.
Well, I just use that as drawing your line. But the orientation would be with that line. See up here? It was natural to you. You did, even though I said axis to outer, axis to edge of the hollow, you did this minus that probably naturally because you're used to it.
Okay.
I still draw from the axis to the outer, from the axis to the hollow, but the right is the axis. The left is the function.
Okay,
Yeah. Let me get rid of the really nasty figure because you don't really need to visualize that. Hold on, pause. Let me get D. Hold on, pause. I just lost what I didn't want to lose. There we go. D, y is equal to 5. Flush or not flush?
Not flush.
Not flush. Because root 3 is definitely below 5. 5 would be, I don't know, up here somewhere, right?
Yeah.
I mean, probably higher, but. dx or dy?
Yeah.
Good. Perpendicular. Axis to the outer. Axis to the edge of the hollow. That's just how you draw the big R, little r. Kyle, another way of saying it, or another reason for saying it, I've never seen the AP write it incorrectly as far as orientation, even though it solves the same. So if you're multiple choice matching, if there's a none of these, and if you had this switch, I need you to know it's the same thing.
Yeah. Okay.
So this is the proper way of writing it. This is what they would have as their multiple choice. Well, they might subtract that and make that a 1, but whatever. They would have it written 4 minus. And if you write it the other way, it would solve to be the same, but technically that is not what they're going to put as the correct representation.
Yeah, because in my mind, I just keep thinking that the big radius is just from the axis to the outer. That's what I'm not from like thinking of it from right minus left or top minus bottom. I'm thinking from the axis to the thing.
But don't let that determine your orientation. And same with, I mean, you know, but this is what they'll put as the right one. Really?
Yeah. For say this is FRQ and they're giving points on setup, would this be taken off?
If you switched it?
Yeah.
That's what I'm saying, not entirely positive, but they could. Because it indicates that you set up the orientation is backwards. Now technically, the long story short, do they want you to have it with the squared and the minus and showing the washer? So they might still give it to you because mathematically it will end up being the same, and maybe your teacher told you like the absolute value, the orientation doesn't matter. But I would say, especially for the matching, why not just make sure it's the right orientation? Alan.
For an FR2 grader, if you jump straight, like for the 4 minus 3 squared, you put that as a 1 square, or like the y squared minus 0 squared. You
Oh,
jump
totally
that,
fine.
like they wouldn't take the point
Yeah.
off it.
And like they probably wouldn't write this in their setup but do not solve. They would probably make it 1 squared, which is just 1. But I'm just making sure you guys see exactly why it is what it is. I'm gonna start writing D, but go ahead, Jonathan, let me know what's going on.
For C, since it's dy, how come it's 3 and not root 3?
Because y bounds is from y equals 0 to y equals 3. Remember this dy was root 3? dx, the x bound is x equals 3, which is y, but the y bound is y equals root 3. Think of x bounds and u bounds, right? You need an x, a u, a u. For dy, I need a y, a y. The y value of the point is radical. So then think of, if I was to mark this, I just didn't mark my y values, but it's from y equals 0 to y equals radical. Does that make sense? And then for this one, it was x equals 0 to x equals 3. Great. Oh, so this one's a dx, so therefore I use my x bounds of 0 to 3. Flush or not flush? Oh, we already answered that, not flush. I have my big R and my little r, so therefore I can go ahead and you guys tell me what's big R.
5 squared.
Because 5's on top, does that make sense? 5 minus?
0.
Good, 0. Which, yes, the AP would just say 5 squared or 25. Minus, what's my little r?
5 minus root
Square root of x. I need it in terms of x. Yes. Oh no, sorry. My finger slipped. Okay. How are we doing? Katrina.
You're gonna ask. Do you pick your points for your bounds
Guys, listen up, might be the same.
based on the solid?
Based on the region that I'm rotating, yes. And the outer parameters, either the x outer parameters or the y outer parameters.
So like if those if the points was like 2 and like 5.
Then that would be a 2, 5. Then that would be a 2. That would be a 5, 5, 2.
Okay.
Yeah.
So it's strictly based on this.
Yeah. Because it's telling you when to start and when to stop. So you have to start at the beginning of the solid and stop at the end. Yeah.
We're revolving around the y equals 5. Why was it 5 minus 1?
Because 0 minus 5 would say that's a negative measurement. And geometrically, we always want a positive measurement. So then that's what we were talking about with the right, left, top, bottom. What's the top of this line? 5. What's the bottom of this line? 0. So think your top, bottom when we're writing it correctly in the correct location. Go picture. Oh, this is easy though. You guys will be able to do that, right?
Yeah.
Is that a harder one? Is that my last one?
Oh.
The shell.
Okay, let me go look at the calendar. Ready, set, go. No picture. You guys got this. You should be able to do it, but make sure you can do it. Go. You're rotating about. Ooh.
What are we rotating about?
I know. Shush.
All of them.
You're rotating about x equals 5. Right? Yeah.
Oh, this is
So the area is enclosed by y equals x, y equals 0, and y equals 4. And it's going about. Oh, did it just take away my about? Okay, oh, like Humpty Dump isn't about. Hold on. I did undo it, by the way. Revolving the region enclosed by y equals x, y equals 0, y equals 4, about the line x equals 5. Ooh, I have to ask you a calendar question. Oh.
Are you sure this thing? Oh, never mind. No, she doesn't.
Katrina.
Yeah. I can't do this wrong. I don't get it. It goes like this.
0 to 4. You can't go to 5. This is go to 5.
Okay. You guys get the right region?
What?
It's definitely triangles.
Yeah, it's not.
Oh,
Yeah,
oh my goodness.
because you only have the one.
No, it's triangles. Just didn't make it straight. It's not a triangle. It's cut off by y equals 4. So you would.
Oh, you keep going, dude.
So
It doesn't go up until the intersection. It gets cut off at y equals 4.
wait.
So when you guys found y equals 4, what was the x? It was not 5.
Equals 4. So wouldn't it be a washer one, not a?
But if no, but it's around 5. Around 5. So it's
Oh, I see. It was enclosed by x equals 5. I should have said both enclosed by and about.
Wait, so what happened?
Oh, so it's not a
if
wash.
it's about if
Alright,
it's around 5.
So according to the way I wrote it, no. According to the way I wrote it, funner. I like my way better, but yeah, you're right. The way I wrote it,
I did.
the way I wrote
We
it,
got it.
the way I wrote it would be this. You're right.
With that?
The way I wrote it, it would be this. Here's my y equals 4. The way I wrote it, it's only enclosed by these.
Yeah, so wouldn't it be the bottom half of that, not the top? Because y, because it's enclosed by y equals 0, which is the bottom.
Yeah.
Yeah, but the problem is, then you don't know how it is. Okay.
Probably.
So,
It doesn't matter whether it's the top or whether it's still the same triangle.
Alright, we're done. Here we go. My bad. I changed it from how it was written, and that was my bad. So, technically, if we did do y equals 0, which you're right is here. If we did do y equals 4, which is here, it's not a triangle. It can't be. But you wouldn't know where to end it. And then we have y equals x, which is right there. You're right. It's something down here. But who told you to stop it at x equals 4?
I did.
Nobody. So therefore, you need to know where to stop it. Do you stop it here? Do you stop it here? Okay, well here, but where do you stop it? Okay, fine. X equals 5 is where you stop it.
Oh, so
There was no x equals 4 stopping it. Something has to stop it.
it's not a wash.
No, it is.
If you stopped it at x equals 4, yes, it would be a washer, but nothing said x equals 4. So therefore, you just had to keep going until something stopped it. X equals 5 stops it. I apologize for my confusing, and what was missing was the about. So we'll do about, if you guys want a washer, sure, about x equals 6. There you go. Now it's a washer. You wanted one, so I gave you one. X equals 6.
I solved it.
Oh, now
I
you're
solved it
solving
with
it.
4.
But you guys are being smart? Oh, with 4?
No, I stopped at 4 going around.
Ah, but nothing said 4.
That's
what I did.
Nothing said 4. But that was my bad. The question would have said, these are the parameters, area enclosed by. I meant it to be around x equals 5. You guys wanted the washer. So, here we go.
Yeah.
Outer.
It's the matter of the one.
Wait.
I was curious.
If it was x equals 4, it'd be 5 minus y. 5 minus y quantity squared minus 5 minus 4 quantity squared. That would have been right. If it stopped at 4 and went to 3. But as it's written now, I would have v equals pi times. You wouldn't need to use y bounds, right? 0 to 4? Because this is going to be a dy. Which means I need to think about this guy as x equals 1. So I'm going to end up with 6 minus y quantity squared minus 5 minus, no, 6 minus 5, sorry. I was helping, I was actually just hurting, I apologize. So let me try to remember what me was thinking a year ago. Anyway. There we go.
See, I have a curiosity.
Yeah.
What would happen if it like told you, it gave you everything, like the parameters you gave, but it said like going around x
Corey, shush.
equals 2?
Impossible.
It would be.
Impossible as far as the volume that it would form. Because if you accumulate one and accumulate the other, they're going to intersect, and so therefore it's like, what, are they cutting each other in half? Yeah, they wouldn't do that. Alright, kiddos, I need to go ahead and show you the idea of cylindrical shells. I need you to realize it's parallel, and I need you to hear me when I say, up until the Chapter 8 test, we will not be checking any more homework in class or going over questions. Instead, I'm going to share the even document with you online. You check the evens, and if you have questions, come to math lab. During period 7, during lunch, before school, or after school. Before school is pretty much just on Wednesdays, maybe on Thursdays, because sometimes we don't have meetings. Because we are now a day behind. We're going to have to finish shells tomorrow, and I cannot try to squish it in. It's a very important topic. We have 2 minutes. 8.4 is not super hard, but we do need to get through it. It has to do with arc length. If worse comes to worse, we won't take a test, and the final will be half the Chapter 8 test and half everything else you've learned ever in math. Worst comes to worst, we could do that. But I need you guys to have your evens not only attempted, but checked. And my people that tend to, let's just say, give less than the optimal amount of effort on homework, please don't let me giving you the even work make you lazier and make you even weaker than you would be otherwise. Sound good? Okay. Volumes, the shell method. Volumes, the shell method. Long story short, we have a region. Long story short, we are rotating around something. Long story short, we're not doing discs or washers. Instead, what we are accumulating are cylindrical shells. What we are accumulating are cylindrical shells. And as we move from the inner to the outer, accumulating little cylinders with little depth, we can find the exact same volume that we would be finding by slicing not parallel, but slicing perpendicular. But instead of doing washers that have a hollow, shells say, hey, start here and here will be done. But we need to talk tomorrow about what the formula is for shells, because guess what? It's not a pi r squared, because we aren't dealing with circles anymore. Not in Kansas anymore. Alright, cool kids, you need to get done with your homework. Section 8.3, anything discs and washers. Pick it out. If you get something with shells, you skip over it. Get ready to do that tomorrow. Bye, guys. I'm sharing the document for the evens for 8.2. It's up to you to grade it. Get a paper. They work hard on them. There's someone, Jessie, with her amazing hair from the play.
You did a good job.